top of page 8. Didn't show up on my screen. Where'd it go? We're going to talk about segment addition postulate first, and then we are going to do 3 examples here. There we go. Now it's doing the right thing. All right, so segment addition postulate tells me if Z is between points A and B. So Z is going to be somewhere in the middle-ish. A and B will be on either side of it.
Teachers at this time, juniors to the auditorium. Juniors and junior teachers to the auditorium. Please escort your students quickly. Get them in and get them seated. Juniors, live up to the expectation of being juniors. Move quickly and get seated in the auditorium.
All right, if you are a junior, you need to go down to the Performing Arts Center. You're going to have to go too, dear. Follow the crowd. They'll show you where to go. Anybody else that is a junior? All right. Make sure you watch the video tonight so you can catch up. I'll talk to you tomorrow about ways to get you caught up in the class. Okay? All right, my segment addition postulate tells me that if I take the 2 smaller segments in the picture, segment AZ, and I put it together with the other smaller segment, segment ZB. When I put those together, I get that larger segment, segment AB. That is my segment addition postulate. And now I want to use the segment addition postulate to write some true and false statements about this line segment here on number 8. On number 8, I have 4 points, A, B, C, and D, in that order on this line. And we're going to write a couple true statements and a few false statements here. I'm going to write down a statement, and I want you to tell me whether it is true or false based on this picture right here. Segment AB plus segment BC is equal to segment AC. Is that a true statement or a false statement? That is true. That is saying if I take this segment right here, AB, I put it together with this segment right here, BC, that would give me a segment that is this long, AC. So that is absolutely true. So we're going to add that to our true list. Is anybody willing to take a risk and see if they can come up with another statement, and then we as a class will decide whether it is true or false? BC plus CD equals BD. What do we think? Do you guys think that is a true statement or a false statement? That is a true statement. Absolutely correct. That we do not put the arrows above this one. That's a really good question. When we talk about segments, so when I'm putting smaller pieces together to build a larger, we don't use the arrows. The arrows tell me that they go on forever, and so then I wouldn't be able to have a measurable piece of it. That's a fantastic question. All right, so that statement, BC together with CD, would give me this whole segment right here. That is why that one is true. All right, I'm going to write another one now, because this is one that I see come up every year. What do we think? True or false?
It's going to be false because I'm trying to trick us.
I'm not trying to trick, but it is one that comes up every year. This is a false one. Let's look at why. AB would be this segment right here. and CD is this segment over here. And what that equation says is that if I take this small segment and I add it to this small segment, I get this whole thing. Why is that false? Yeah, because you guys are absolutely right. We missed that middle chunk. If I wanted to write a true statement like this, I would have to include that middle piece. Can somebody help me write that one that would include the middle part? Yes. Absolutely correct. AB plus BC plus CD equals AD. I like it. All right, what about AC plus AD equals CD? True or false? False. What that one is saying is that if I take this segment right here, and to that I add another segment that is this big, when I add those two together, it would give me this little piece right here. That doesn't make any sense. I can't add two bigger things to get a smaller thing. We'd have to subtract. Let's write that down in the true statements then. Which one is the biggest one? AD. So I'm going to take AD, and then I could take away AC. If I have that whole line segment AD, and I take this much of it away, I'm left with CD. Nice work. There is a homework problem where I ask you to write a true statement. It'll describe a line that you need to draw, similar to this, only you'll have to draw the line in there too. And then it asks you to write a true statement about it. So something like this, or like this. All right, let's list all of the distinct line segments in the picture. And I want to walk you guys through my method for making sure I get them all. Because on a picture like this, I feel pretty confident that I can find all the line segments. But when you start adding more and more points, more and more parts, it gets a little bit harder to make sure I'm getting all of them. So here's the way I walk through to make sure that I've got all of them. First thing I do is I start on the far left point, and then I look at the point just to its right. So AB, that's one of my segments. So the first 2 points. Then I scoot over 1 point, and I look at this little chunk from B to C, so the second point and the third point. Then I do the third point and the fourth point. So there's 3 line segments. So far we've gotten this one, and this one, right? Then I go back to the beginning. Once I've hit the end on the left-hand side, once I've gotten all the way to the very last point, I start back at the beginning. I start with this first point. I already wrote the line segment where I go just to the very next one. So now I'm going to skip that one and go to the third one over. So first, skip, and then here. So segment AC. So from A to C, then I move 1 point over and I do it again. Point, skip, point. B to D. And then if there were more points on here, I would do it to the next one over. Third, skip, point. So C to E if there was a point E up here. And I would keep going until I hit as far to the left or far to the right as I can go. Then I start back over the beginning. I've already done skip 1, so now I'm going to skip 2. Start at the first one, skip, skip. And then that point. So from A to D. And I can't do that for any other points. B and then skip, skip I don't have another point over here. But if I had another point over here, I would do B, skip, skip, E. So B to E. So far, so good? Okay. You don't have to use my method for it, but that's the way I walk through so that I make sure I get every single one and I don't miss any of them. I have this pattern that I follow. All right, let's do a couple examples now. We're going to be using the segment addition postulate, and we're going to be using what we learned yesterday about congruence. Does anybody remember what the word congruent means? Yep, same size, same shape, so their measurements are equal. Yes. All right, let's look at number 9. For 9 and 10, I both noticed something missing from my problems that I absolutely need to work with. Yeah, I need a line segment. We need to draw it in if they didn't give it to us. So I draw the line segment in first. What point goes somewhere in the middle of this line? Point B. It says point B is in between. So I'm going to pick a spot somewhere on that line segment, and I'm going to label that as point B. What do we call the two end points on this line segment? A and C, yes. All right, now they give me some information that I'm going to add to my picture. They tell me that segment BC is 6x plus 5. So from B over to C is 6x plus 5. What'd you say? Confusing when you had to kind of draw it in? Oh, got it, yeah. So writing down that equation we'll get to here in just half a second. What happened here? My points all got messed up. Sorry guys, I don't know what happened there. There we go, try that again. AC is 98. So from A all the way over here to C is 98. And then the last piece of information they give me is that segment AB is 8x plus 9. So from point A over to point B, eight x plus 9. All right. So first thing we do is we add it to our picture. After that, we're going to write down an equation. Did they tell us anything about things being congruent? No. If they don't tell me anything about congruence, and I'm supposed to solve or find something, then I'm going to have to use the segment addition postulate, because that's the only other tool that we have right now. It says find the value of BC. My segment addition postulate tells me that I take two smaller segments and I put them together to get a larger segment. I want to do this with the names of the segments. So A, B, and C are things that I'm looking for. What is the name of one of the smaller segments? We're going to write that down here in just a second, but what segment does that go with? AB, yes. AB, and in the place of AB, you're absolutely right. We're going to substitute in 8x plus 9. All right. What is the name of the other smaller segment that's being joined to AB? BC. And how big is segment BC? 6x plus 5. And when I put segment AB together with segment BC, what's the big segment that I get from doing that? 98, which is segment named AC, yes. We're going to put 98 in the place of that AC. Tip for success in geometry. Don't skip writing this top part. Writing down that segment addition postulate first and then substituting in the pieces means that you are more likely to get that problem right. Without writing this part down, it becomes very easy to mix some of these pieces up and put them in the wrong spots. When you write down your segment addition postulate and then you substitute in, you're more likely to get things in the correct spots. All right. So now we're going to solve this like an Algebra 1 problem. First thing I do is look on each side of the equal sign to see if there is any like terms that I can combine. Looking just over here at the left, are there any like terms that we can combine together? Yes. What can we combine? 6x and 8x. What do I get when I combine those two together? 14x. Are there any other like terms over here that I should put together? 9 and 5, which is 14. I would like you guys to finish solving this for x, and we'll check back in here in just a second. No, that's not you. Oh, I think this is an older one that I printed. This one is yours, isn't it? Okay. S-A-I-M? Oh, I apostrophe?
No, just apostrophe.
Just an apostrophe. S-A apostrophe M-Y.
Is it?
U-H?
Yes.
Okay.
What kind of do you like? I don't know.
What am I sending you for? I'll give you both of those things. You're welcome. All right. Walk me through what I do. What's my next step? Subtract 14 from both sides. So that gives me 14x equals what? 14x equals 84. Kind of ran out of room, so I got to bring my work around here. 14x equals 84. And then what? Divide both sides by 14. What is 84 divided by 14? 6. X equals 6. So we're done now, right? Why am I not done yet? We have to substitute. What are we substituting into? The x spots. Into which of these expressions? Which one do I want to substitute into? 6x plus 5. BC is equal to 6x plus 5, and we're going to substitute 6 in the place of the x. So I have 6 times 6 plus 5. What is 6 times 6? 36 plus 5? 41. So BC is 41. All right, so steps for these problems. Draw your picture first if there's not a picture. Mark the picture up with any information they gave you. Write your segment addition postulate. All right, let's look at number 10. What do I need to do on number 10 first? Yep, make our line segment. Which one goes in the middle of the line? B. So somewhere like here. And my endpoints are called what? A and C again. Does it matter which side I put the A on, which side I put the C on? Nope. I tend to do it from left to right just because that's what I'm used to. That's what looks normal. But it's okay if I switch the A and the B around. right, segment AB is 5x minus 14, so I'm going to add that to my picture. 5x minus 14. BC is 4x. So from B over to C is 4x. Did they give me any other information to work with? AB and BC are congruent. If they're telling me that in the problem, it's probably going to be important and I'm probably going to need to use that information to solve this. What do we do with the measurements of things that are congruent? I'm looking for an E word. What do we do with the measurements of things that are congruent? We're going to set them equal, yes. If segments are congruent, set the measurements equal. All right, I'm going to mark it on my picture too. AB is the same size as BC. What are we supposed to find? AC. So we need to know how big it is from here all the way over to here. So now I'm going to write down my segment addition postulate. What are the two smaller segments being put together? What are the names of the two smaller segments that are being joined? AB and BC. So AB plus BC. And when I join them together, I get what? We get AC. Do we know how big AC is? Did they give us a number or an expression that we can substitute in for AC? No. So that means I'm going to have to figure out how big AB and BC are by themselves and then put those two numbers together. This is where the congruent part comes in. What do we do with things that are congruent? Set them equal. AB is congruent to BC. So the measurement of AB equals the measurement of BC. No line over the top means the measurement. What do I put in the place of the measurement of AB? 5x minus 14. And I set that equal to, what do we put in the place of BC? 4x. Now we need to solve this for x. What do I need to do first if I'm going to solve this for x? I can add 14 to both sides. Now that 14 and 4x, will they combine? No, 14 is not a like term with 4x. All right, so I have 5x equals 4x plus 14. That didn't help me get my x all by itself, but it did make the 14 positive, which is nice. What do I need to do to get the x's together on one side? Subtract 4x. My personal preference is that we would have done that at the beginning, like we would have done that as our first step, and then added 14 to both sides, but there's nothing wrong with doing it the other way around. Yes? You started with the x's, which is what I would do too.
Yeah, I still got the same answer.
Yep. So you just need an equal sign in between those two. All right, so I get x equals 14. So every single class period today so far has done this differently. First period, when I asked them, what are we going to do right here, they said minus 5x from both sides, which is absolutely an okay thing to do. that would give me a negative 14 equals negative 1x. And then I divide both sides by negative 1. I get that x is 14. We could have started by minusing 4x from both sides. That would have given me x minus 14 equals 0. And then add 14 to both sides. We get x equals 14. As long as you're doing it to both sides and you take care of any addition or subtraction before you start doing any dividing, you should be okay. All right, so I got that x is 14. Now I need to use that to figure out how big AB and BC are. AB, 5x, so 5 times 14 minus 14. What is 5 times 14? It's 5 times 14. Put away. Put away. 70 minus 14. Yep. Close, 56. That's okay, 56. So from A to B is 56. So I can put 56 in the place of AB. Before I even do any plugging in, what do I already know about BC? It's congruent. So when I plug it in, what number should I get? I should get 56, yes. Grab a calculator, do 4 times 14 and tell me what you get. 56. Those two segments are congruent to each other. So they came out to be the exact same size. And then I just have to add 56 and 56 together. What is 56 plus 56? 112 is equal to AC. All right. Something I want to talk about real quick before we go do our very last problem. This point right here, B, that point is dividing my big line segment into 2 equal parts. So it's not just somewhere on that line segment, it's in the exact middle. This is the middle point or the midpoint. If I have a point and on either side of it I have congruent segments, on either side of it they're the same size, that is our midpoint. It's cutting my line segment in half. I can actually use that to shortcut this if I wanted to. Instead of adding 56 plus 56, I could also do 56 times what? What would be the same as 56 plus 56? 56 times 2. So 2 times segment AB would also give me the same size as segment AC. That would be 2 times 56, which is 112. If I have midpoints, I can do 2 times that instead of finding both of them and adding them together. You can do it either way. All right, we have one last problem that we're going to do, number 11. And you have a problem almost identical to this one on your homework. And people have already been asking me about this one off the homework today. So take careful notes on this, follow the pattern, and then try it on the homework. They gave us a picture. Yay! We're going to mark our picture up. Segment AB is 6x plus 14. So from A over to B is 6x plus 14. From B over to C is 4x plus 28. And then from C over to D is 43 minus x. What do they want me to find here? They want me to find AD. That's this whole big thing here. Help me write segment addition postulate for this. What are the smaller segments that I would put together to get that big segment? AB plus BC plus CD equals AD. Do we know how big any of those are yet? No. I have expressions for 3 of them, but I don't actually know how big they are. Did they give us any other useful information? Yeah, BC is congruent to CD. When we see congruent, what do? I'm looking for an E word. Set equal, yes. Let's mark our picture first. It says BC, that's this one, is congruent to CD. It's important that I mark it so I know which pieces I'm setting equal. Well, if BC is congruent to CD, that means I need to take BC and set it equal to CD. What should we replace BC with? What substitutes in? 4x plus 28. So 4x plus 28 is equal to what? 43 minus x. I want to solve this now for x. What's my first step? Add x to both sides. Let's get rid of that negative x. I'm going to add it to both sides. It's going to cancel out over on the right. 4x plus x gives me 5x. So 5x plus 28 equals 43. What next? Subtract 28 from both sides. What is 43 minus 28? 15. If 5x is 15, how big is x? X is 3. We're going to divide both sides by 5. We get that x is 3. Now that I know x is 3, can I come in and figure out how big AB, BC, and CD are? Yes. So AB, 6x, so 6 times 3, plus 14. What is 6 times 3? 18. 18 plus 14? Close. 32. So in the place of AB, I'm going to put 32. And then we have BC. Our expression for BC was 4x plus 28. So 4 times 3 plus 28. What's 4 times 3? 12 plus 28? 40. Yep. So replace BC with 40. Last one we have is CD. CD is 43 minus x, and x was 3. So how big is CD? 40. I knew before I even substituted in that was going to come out to be 40. How did I know that? Yes. These are congruent. Same size. You're absolutely correct. We get 112 here. Since AB and BC are the same size, I could have just found BC and then doubled it. We could have said AB plus 2 segments the size of BC is equal to AD. That would have given me 32 plus 2 40s, and I get 112 that way too. So you can do it either way. You did not have to substitute in for CD. We knew from here it was going to come out to be 40, and so we can just double it. If they're the same size, if they're congruent, you don't have to sub in for every single piece. All right. Homework number 2 is due tomorrow. The 3 examples that we did today, 9, 10, and 11, those will help a lot with the back side of the homework. First thing we're doing when you guys come in tomorrow is grading that homework. You're going to correct anything that you got wrong, and then we'll turn that in. Then we'll do a little bit in your pink notes packet, and with the last 10 minutes, you guys will do a skills check.